discuss for cooling methods. Okay. So now we'll see why cooling is necessary for the transformer and what are the different methods of cooling the transformer. Okay. So now just I want to know why cooling is necessary for transformer. Can anybody answer to my question now? Yes. Why cooling is necessary? Why cooling is necessary for transformers?
Because to reduce the heat, due to heat itself, the losses are occurs in the transformer.
Due to the heat, or heat will cause the or losses will cause the heat.
Losses will cause the heat.
This type of losses usually
Copper loss, sir.
copper losses. Good. So usually when we are going to load the transformer, it is going to draw the secondary current. Due to that, copper losses will take place, and because of that, those copper losses will appear in the form of the heat, right? So now this heat, it has to be dissipated from the transformer, otherwise it is going to damage the insulation. Also it is going to damage to the entire transformer. For that sake, we should what is that, evacuate, we should dissipate the heat from the transformer. Okay, all of you join immediately. See here, let us see the explanation part for cooling off, methods of cooling off a transformer. When transformer supplies a load, two types of losses, occurs in a transformer. Still many of the students, they are joining. Right now 41 students, they have joined to the class. Let us see here. When transformer supplies a load, two types of losses occur inside the transformer. First is iron losses occur in the core, while copper losses occur in the windings. It will be occurring in the windings. The power lost due to these losses appear in the form of heat. Heat increases the temperature of the transformer. So usually transformer, it is having two main parts, that is core and windings. Core is made up of iron and windings, they are made up of copper. Because of this, certain losses will be taking place, which we call it as iron losses or core losses in the core part of the transformer, and copper losses, which is going to take place in the windings, which are made up of copper. And see that these losses physically, they will appear in the form of heat, and whatever the heat it has been generated or developed in the transformer after loading in the transformer, we need to dissipate this heat, right? If we don't dissipate this heat from the transformer to the outside atmosphere, then transformer insulation may damage. It may lead to the short circuit of the windings. For this sake, what we are doing, we are going to provide the cooling. Okay, let us see here. Key point. To keep the temperature rise of the transformer, within limits, it is necessary to dissipate the heat developed to the surroundings. So whatever heat it has been developed, it has to be well within the limits. To keep the temperature rise of the transformer within limits, it is necessary to dissipate the heat developed to the surroundings. So whatever heat it will be developed, it should be within the limit, right? So to keep the temperature within the limit, we are going to follow certain cooling methods here, right? A suitable coolant and cooling method is necessary for each transformer to dissipate the heat effectively to the surroundings. So here we are using certain coolant. Coolant means which is going to extract or which is going to absorb the heat from the transformer inside tank. Okay, and certain cooling methods we are going to make use here. Okay, basically there are two types of transformers. But there are two types of transformers. Dry type transformers and oil immersed transformers. So usually if you look at the operation of different types of transformers, it will be categorized into two categories, that is dry type transformer and oil immersed transformer. Dry type means what? There is no oil inside present in the transformer, means for cooling purpose we are using certain mineral oils here. So if oil is absent, then those type of transformer we call it as dry type transformer. And for cooling purpose, if I use some mineral oil, then that type of the transformer we call it as oil immersed transformers, right? Then in dry type, the heat is taken to the walls of the tank and dissipate to the surrounding air through convection. So usually, suppose after loading the transformer, it is going to have certain copper losses because of current run from the primary to the secondary, then to the load. So this copper loss, it is going to cause certain heat, right? And that heat, if it is developed in the dry type transformer, then their oil is not present to carry the heat. So there, naturally what it is going to happen is, it is the heat, whatever it is there, it is transferred to the walls of the transformer through the air by some means of what is that, heat carrying method. That heat carrying method is nothing but convection method here. Okay, so this convection method, in this we are not going to make use of any mineral oil. Directly whatever heat will be developed in the dry type transformer, that heat will be taken to the walls of the tank via some air media, and that air media means here we are going to following convection cooling method. Convection cooling method. Okay, then similarly, what if the case it is oil immersed type? Okay, in oil immersed type, the oil is used as a coolant. So here we are using certain mineral oils to carry the heat. The entire assembly, including core and windings, is kept immersed in a suitable oil. So here what is the thing going to happen is, the entire core as well as the winding part, it will be housed inside a tank, and then that tank will be carrying certain oil, and inside that oil we are going to place both the windings as well as the core, so that whenever heat will be developed, that heat can be easily carried by the oil. Okay, the entire assembly, including core and windings, is kept immersed in a suitable oil. Then the heat developed is transferred to the walls of the tank by convection through air. So in the dry type, there is no oil, but here now oil is present. So whatever heat is developed through the windings, that heat will be absorbed by the oil, and that oil, which is going to carry the heat, then further it is going to uh, reach to the tank walls of the tank, and from the wall tank it is given out to the atmosphere. So once again, here also we are going to follow convection type of heat carrying method. Okay, then and finally heat is transferred to the surroundings from the tank walls by radiation. Then from there onwards, it is going to follow the next method of heat transfer, that is radiation method. Okay, so this is how we are going to dissipate the heat if it is what is that, dry type, and if it is oil immersed type. Now let us see the different cooling methods here. The various cooling methods are designated using letter symbols which depend upon, first one, cooling method used, or sorry, cooling medium used, and second is type of circulation employed. So usually whenever we are going to cool the transformer, there are different cooling methods. So which type of cooling method we are using, so that method we are going to denote it by some English letters or English symbols. So based on that, we are going to classify into two types. One is cooling medium used, means what type of medium we are using, whether you are using air, gas, or some mineral oil or some synthetic oil. Okay, then you can see here cooling medium used and type of circulation. So how that medium is circulating. Okay, the various coolants used along with their symbols are, so suppose if I use cooling medium as air, then that method, cooling method, simply it is denoted as capital letter A. It is simply denoted as capital letter A. If we are using gas, then it is denoted as capital letter G. If you are using some synthetic oil, then we are using capital letter L. If I am using some mineral oil, then English capital letter O. Similarly, if I use some solid insulation, then English capital letter S. If I'm using water, then English capital letter W. So all these are the different notations for indicating which type of coolant you are using for cooling the transformers, right? If you use air, then cooling method, it is denoted as capital A. If I am using gas, capital G. If I am using synthetic oil, capital L. If I am using mineral oil, capital O. If I am using solid insulation, capital S. If I use water, capital W. So all these are the notations which we follow for indicating types of coolant you are using for cooling the transformer. Okay, then there are two types of circulation. So after seeing which are the different types of coolants, now let us see how we are going to circulate all these coolants to carry the heat developed inside the transformer. So there are usually two types. One is natural, this is natural, not neutral. This is natural method, and second one is forced. So natural method, here it is denoted as neutral, it is not neutral, it is natural. Okay, natural, it is denoted by capital N, and second one is force type. Force type means it is denoted as F. So how I am going to introduce, or how I am going to inject air or gas or synthetic oil or mineral oil or solid insulation or water to carry the heat inside the transformer, whether I am going to force it naturally or I am going to force it by some means. So based on that, there are two types of circulations. Now let us see what is meant by natural and what is meant by force type. Okay, in natural cooling, the coolant circulating inside the transformer transfers entire heat to the tank walls, from where it is dissipated to the surroundings, and transformer gets cooled by natural air circulating surrounding the tank walls. So you can see in natural cooling, the coolant circulating inside the transformer transfers entire heat to the tank walls, from where it is dissipated to the surroundings, and transformer gets cooled by natural air. So here we are not going to inject by forcefully all these coolants altogether. Suppose if I use natural air, so then that natural air itself, it is going to carry the heat what is that present inside the transformer from the windings, from the cores, and then it will be carrying to the walls of the tank naturally. Here we are not going to force that air purposefully. Naturally the air will carry the heat. Okay, so if that is the type of method, then that we call it as natural cooling. Okay, forced type, let us see what is this. In forced cooling, the coolant circulating inside the transformer gets heated as it comes in contact with the windings and cores. So here we are forcefully, we are going to inject some coolant, that might be synthetic oil or some mineral oil. So whenever this coolant, mineral oil or some synthetic oil, it will come in contact with the windings which are heated, then that heat of the windings, it will be carried by this coolant, by this coolant. Okay, the coolant partly transfers heat to the tank walls, but mainly coolant is taken to the external heat exchanger, where air or water is used in order to dissipate heat of the coolant. So usually in the force method, we are going to force some coolant, that will be either air or gas or some synthetic oil or some mineral oil. So by the time when I forcefully inject this one, all these coolants, what they will do, whenever they will come in contact with the core or heated core or the heated windings, it will carry the heat, and that part of the heat, it will be sent to the walls of the transformer, and remaining part of the heat, it is going to dissipate the heat via the heat exchanger. So that heat exchanger, what it will do, it will absorb the remaining heat, whatever that is absorbed by the oil, and from there the heat exchanger, it is going to release all the heat to the outside atmosphere. Okay, so this is the method of force type. Is it clear, all of you? Natural means we are naturally, it will carry the heat. Force type means here there we are going to purposefully, we are going to force some coolant. So that coolant, what it will do, part of the air, part of the heat, it will be sending directly to the walls of the transformer, and remaining part of the heat, it is going to exchange it in the heat exchanger. And what is the function of heat exchanger? Heat exchanger, simply as the name says, heat exchanger means it will be exchanging the heat. So earlier it will be in cold state. That cold state heat exchanger, it will absorb all the heat, and whatever the absorbent it is there, that absorbed heat will be given outside to the atmosphere. By this time, the transformer temperature will be lowered. Is it clear? Do you have any doubts? Yes?
No,
Is it clear or do you have any doubts? Shall I move to the different methods now?
sir.
Okay. Now let us see the cooling methods by dry type transformer. So as I told you, there will be two types. One is oil immersed or and another will be dry type. So if the transformer is dry type, then what type of cooling methods we are going to use? Okay. See here, the cooling methods of dry type transformers are classified as air natural, right? Then another is air blast. So here you can see that what is the coolant we are using here? Coolant is in both the cases. Coolant is what? Air or oil?
Air.
Air. But how that air is we are going to inject? In, in first case, we are going to send the air naturally, and in second case we are going to compress the air, and that compressed air we are going to blast it inside the transformer so that it is going to carry the heat. So this is natural cooling. First one is natural cooling and second one is forced cooling. Are you getting my point? Yes. Now let us see the notation for air natural is English capital letter A, capital A, capital N. So AN indicates air natural type of cooling methods. Okay. Now let us see this air natural method, how it is going to carry the heat and for up to what rating this method is usually applied. Okay. This method uses atmospheric air as cooling medium. So this method uses what? Atmospheric air, natural air, whatever it is present in the outside atmosphere, the same air we are going to use it here, natural air. The natural air surrounding the tank walls is used to carry away the heat generated by natural convection. So whatever air it is there outside the atmosphere, the same air it will carry the heat, whatever that is developed inside the transformer. Okay. It is used for small voltage transformers. So for small rating transformers, we are using. Why small rating means heat will be very less that is developed inside the transformer and it can be easily carried by the natural air. Okay, no need to have some compressed air and all for this purpose. Due to the available insulating materials like glass and silicon resins nowadays, the method can be used for the transformer up to ratings 1.5 MVA. So this method can be used only for small voltage type transformers, and now the technology is advanced where I can make use of the insulating materials like glass and silicon resins. Due to that reason, what we can do by making use of the glass and silicon resins with and that too with the air natural method, this method is can be extended, then can be used for the transformer up to the rating 1.5 megavolt ampere, that is 1.5 MVA. Okay, so here air is given in the natural method where natural atmospheric air will carry the heat, and this can be applied for small voltage rating transformer. And if the insulating material will be like glass and silicon resin, and then this type of transformer which is dry type, this can be used for voltage rating up to 1.5 MVA. Is it clear? Now let us see air blast type. Air blast means here we are going to condition the air. It is not the natural air now, some conditioning will be done here. Okay. In large transformers, cooling by air, natural air is inadequate. So suppose if the rating of the transformer is very large, suppose if the rating of the transformer is very large, then natural air is not sufficient enough to carry the huge amount of heat, because in the large rating transformer losses will be more, then heat will be more, then natural air is not sufficient to carry the heat. In that case, some advanced air we have to use. That advanced air is nothing but what? Some compressed air or some conditioned air. Okay. In large transformers, cooling by natural air is inadequate. In such cases, the transformer is located above the air chamber and a blast of compressed air is forced on core and windings with the help of blowers or fans. So here what we are doing is we are going to treat the air. We are going to condition the air. For conditioning purpose and all, we are using some air chamber and some air compressors where air will be compressed to high pressure, and then that high compressed air, it will be blasted onto the core and the windings with the help of what? Blowers and fans. So blower and fans are nothing but the outlet through which I can pass the compressed air onto the windings and the core, so that whatever heat will be there, it can be easily extracted there. Okay, this improves the heat dissipation and hence higher specific loadings are allowed in dry type transformers. By doing this, we can carry huge amount of the heat, and if we carry huge amount of the heat means we can load the transformers to large loading condition, because as and when we increase the load, automatically losses will be more, automatically heat will be more, and see that whatever heat will be developed, that is going to give rise to the temperature that has to be carried out safely, because if the heat will be there inside the transformer tank itself, then it is going to cause insulation damage and all. For that sake, we need to have some cooling method with the help of air blast method. This reduced the size of transformers. Because of this case, because of the air blasting method, heat can be easily taken out. Because of the easy cooling of the transformer, automatically size of the transformer gets reduced. This is the meaning here. The air supply must be properly filtered to prevent accumulation of dust particles. So here, whatever air we are compressing, whatever we are blasting onto the windings and the core, that air should be free from the residue particles. Residue particles means whatever dust particles it is going to have, it should be filtered from the dust particles. Otherwise, those all unwanted particles, they may get deposited onto the core and the winding. Because of that, damage to the core and winding may take place. Okay, it should be completely filtered. Now let us see cooling methods for oil immersed transformer. So the cooling methods for dry type transformer is air natural and air blast type. Now let us see the cooling methods for oil immersed type transformers. Okay. Now before going to see the methods, let us see why we are using why we are using oil here. What is the function of the oil? Okay. The oil used as a coolant has following advantages. Why we are using oil in the transformer is because it is good conductor of heat than air. So if we compare oil and air, which are the coolants, from those two, I can say that oil has more heat carrying capacity as compared to the air. For that sake, we are using oil. So it is a good conductor of heat than air. Then apart from that, let us see what is the advantage. It has high coefficient of volume expansion. So it can be easily having high coefficient of volume expansion. Due to this, adequate circulation is easily obtained. So we can supply a huge amount of the oil because of the high coefficient of volume expansion. Then oil acts as an insulating medium, which increases the insulating strength. So not only it is going to carry the heat that is present inside the transformer tank, it is also going to provide the insulation for the windings as well as for the core part. For that sake, we are using the oil here. That too, it is mineral oil. Okay. The only limitation of oil immersed transformer is that these transformers cannot be used at places like mines where there are chances of fire hazards. So the drawback of this oil immersed type transformer is that this cannot be carried at the underground places like mining activities and all, because oil may catch the fire. For that sake, looking to the constraint of fire and all, we should not use this oil immersed type of transformer at the mining activities like places. Okay. Now let us see. Can you hear my voice, all of you? Yes?
Yes, sir.
Okay. Now let us see the various cooling methods for oil immersed type of transformer. The first cooling method is oil natural. So remember, now we are going to see different cooling methods for oil immersed type here, where oil will be used. So first one is what? Oil natural. So oil natural, let us see. So this is the diagram for oil immersed transformer, and that too, it is oil is transferred naturally. So this will be denoted as capital O, capital N. It is not on, it is oil natural method, which is denoted by the English capital letter O, English capital letter N. ON stands for oil natural cooling methods. And this method, we are using it for which type of transformer? Whether dry type or oil immersed type?
Oil immersed.
Oil immersed type. Okay. And now you only tell me, the first method is oil natural. Oil natural means what? Are you going to forcefully inject the oil, or oil will naturally carry the heat?
Oil will naturally carry the heat.
Oil will naturally carry the heat that is present inside the tank of the transformer, right? So this is diagram for the oil immersed type of transformer, where it is going to have some tubes to carry the heat, and then this is the transformer tank. Inside the tank we will be having what is that, all the windings here. Okay, see here, the transformer is immersed in oil, so the whole transformer core as well as the windings all together they will be inside, immersed inside the tank, and this tank will be carrying the oil here. Whatever dotted portion you are seeing here, this is all nothing but oil which is moving freely through the tubes and all. Okay, and when the transformer is immersed in oil, so heat generated in core and windings is passed on to oil by conduction. So here by conduction method we are going to carry the heat. Okay, and then whenever oil is passed through this core and the windings, then that oil will take the heat, it will absorb the heat, and whenever the oil it is going to reach to the tube, and these tubes they will easily uh, evacuate, they will easily dissipate the temperature to the outside atmosphere via these tubes. Okay, tubes will be given for cooling purpose here. I hope you have seen this kind of structure of the transformer. Have you seen, all of you? Have you seen
Yes, sir.
tubes and all? Those tubes are nothing but for cooling purpose. We are using the tubes. Whatever heat will be developed inside the transformer because of the heating of winding and the core, there there might be some natural oil or some air which will carry the heat. That heat it will travel from the windings and the core, and then it passes through the tubes, means then those tubes which is having the heat that is given out from the winding and the core, they will be given out to the atmosphere directly by means of some heating method, that is either by convection or by conduction. But here by using oil, the heat is transferred or exchanged by the method of conduction here. Okay, the heated oil transfer heat to the tank where from all from where it is taken away to the surrounding air. So surrounding air it is going to carry the heat. The assembly of the oil immersed transformer is shown in figure dot one. So this is the figure dot one where we are going to have oil immersed type of transformer, and oil is used for cooling purpose, that too naturally. Naturally we are going to add the transformer oil, and then that oil it is going to carry the heat from the windings and the core. Okay, the tubes are provided on sides, on the sides of a transformer tank. You can see the tubes here. Tubes are provided on side of the transformer. The oil in the tank is taken to the tube, so the oil it is going to be taken or carried away by the tubes also. The circulation of oil through tubes causes the cooling. So whenever the heat carried oil it is passing through the tubes, then heat will be easily taken from through the tubes to the atmosphere. Now, the temperature of a transformer can be reduced by how temperature we can reduce it by increasing the area of the heat dissipation. So here we need to increase the area of the heat dissipation. Then similarly, decreasing the cooling coefficient. Decreasing the cooling coefficient means it is based on the construction part, design part of the transformer. Okay, so this is all about oil natural cooling method, where natural oil we are going to use, and that oil it will be carrying the heat, and it when by the time it passes through the tubes, from the tubes that heat will be passed to the outside atmosphere, surrounding atmosphere by conduction method. Okay, now as the rating of the transformer increases, the plain walled tank cannot be used. It is necessary to reduce the cooling coefficient. This is achieved by use of some improved cooling methods. So now, if I increase the transformer rating, then the same natural cooling method is not sufficient enough to cool the transformer. So in that case, what we have to do, we have to decrease the cooling coefficient. So as I told you, cooling coefficient is nothing but what? It is the change in the design part of the transformer. So how that cooling coefficient can be reduced, and how this natural cooling can be facilitated very effectively, that too for large rating transformers, that we can see here. As the rating of the transformer increases, the plain walled means this is plain walled transformer. Okay, tank cannot be used. It is necessary to reduce the cooling coefficient. This is achieved by use of some improved methods of cooling. So here further we have to make some alterations in the cooling method. That alterations let us see here. The transformers up to 30 kVA use plain walled tanks. So if we are using oil immersed type transformer, and that too if it is up to 30 kVA, then we can use plain walled tanks. Okay, but transformer ratings higher than 30 kVA use corrugations, fins, tubes, and radiator tanks. Means up to 30 kVA I can make use of this plain walled tanks. Okay, but if the rating of the transformer is beyond 30 kVA, beyond 30 kVA, The same plain oil tanks will not serve better for cooling the transformer, because there heat will be more. As rating will be more, heat will be more. That heat will be not dissipated very effectively by normal plain oil tank. For that sake, certain alterations we have to do. So those alterations are nothing but by making use of certain corrugations, fins, tubes, and radiator tanks. So now figure dot 2 shows fins and corrugations provided on the wall tank. So now the earlier plain tanks, plain wall tanks, now they are going to have certain modifications in the construction. So those modifications are nothing but what? Fins and corrugations, fins and corrugations. So you can see that this is the wall tank, inside wall tank, where it will be having certain extra projections. So those extra projections are nothing but the fins, these are nothing but the corrugations. So by providing this kind of the constructions inside the wall tank, this will dissipate the heat to the faster rate, and this method, it is going to decrease the cooling, what is that, it is going to decrease the cooling coefficient. So to have better cooling coefficient, to decrease the cooling coefficient and to increase the cooling method, that too for more than 30 kVA rating transformer, we are going to make use of fins and corrugations here, fins and corrugations. So these are nothing but what? This will serve better for fast cooling of the transformer. Is it clear? And this type of the modification we are going to provide for the transformer wall tank, that too with the transformer rating more than 30 kVA. Below 30 kVA, plain wall tanks is sufficient enough. But if it is more than 30 kVA, then some more faster heat dissipating method I should apply. So that faster the heat dissipating method is nothing but what? It is nothing but change in the or modification in the construction part of the wall tank, that is nothing but fins and corrugations. Okay. Now figure dot 3 shows the tanks with tubes and external radiators. So now this is all about fins and corrugations. So apart from that, we are going to make use of what? Tubes and radiator tanks. Tubes and radiator tanks means these are the tubes side to the tank of the transformer. We are going to make use of the tubes. So this is the tank, means this is the tube. Similarly, here we are going to make use of some external radiators. You can see here, winding and core will be here, and whereas that this is the entire main tank, and side to that it will be having some external radiator. I hope you know about the car and all. In the car also you will be having some radiator. So what is the function of the radiator in the car? Yes. Why are you using the radiators? Can anybody? Can you hear my voice or not? All of you. There also, whatever heat it will be developed inside the engine and all, it has to be given out to the outside atmosphere, yes or not? For that sake, we are using some radiators here. In the same way, here also we are using some radiators side to the transformer. You can see here also there is a radiator. This is also radiator. Similarly, here also the tubes. These are the fins and these are the corrugations. So all these are the different alternative methods for better cooling of the transformer with the rating more than 30 kVA, and that too to reduce the cooling coefficient. If it is less than 30 kVA, then use simple walled tank. Okay, so these are all the special type of alterations which we are going to view for fast cooling method for the transformer more than 30 kVA. Is it clear? Now, the heat developed inside the transformer is taken outside with the help of oil. The oil is cooled with the help of fins, tubes, or external radiators by natural circulation of air. So here inside the inside it will be their oil. This oil, what it will do, it will carry the heat from the windings and the core, and then if by the time it touches to the fins or corrugations or tank or any external radiator, all that heat will be exchanged there. All that heat will be exchanged, and further air will also carry the heat, and that whatever oil is heated now, by the time it passes to the or reaches to the fins or corrugations or tubes or the radiations, apart from the exchange, heat exchange is going to take place, even air is also going to cool that hot oil. So this is how we can cool the transformer very effectively for the rating of the transformer more than 30 kVA. Okay, hence these methods are called oil natural and oil air natural. So here we are using oil as well as we are using air for cooling the transformer, and that too naturally. For that sake, this method is called as oil natural and air natural. In short, it is called as ONAN method. ONAN stands for oil natural, air natural method. Okay. The tubes are used for the transformer up to ratings 5 MVA. So if I'm using some tubes of this kind, then this type of cooling method is going to serve best for the transformer rating up to 5 megavolt ampere, up to 5 MVA. This type of tubes can serve the best method for cooling of the transformer. Right. Now, the next type of the cooling method in oil immersed type of transformer is oil natural air forced. Oil natural air forced means what? Here, oil we are going to pass it naturally, but some but some compressed air we are going to blast it, so that compressed air it will carry the heat from the oil. Then that method we call it as oil natural air forced, ONAF. In short, it is called as ONAF. Let us see. In this method, the tank is made hollow and compressed air is blown into the hollow space to cool the transformer. Okay, the oil circulating inside takes to the tank walls. The method is effective and can be used for large rating transformers. Another way to force air blast is to use elliptical tubes separated from the tank walls, through which air is forced by fans. So here what we are doing is there will be a large rating transformer having its own tank. Inside the tank we are going to place oil, windings, core. So whatever heat will be there inside the oil tank, that it will be carried by the oil, and that oil which is heated now, that heat will be taken by blasting the compressed air, by blasting the compressed air. This is the one method. Or otherwise we can also make use of some elliptical tubes which is separate from the wall tanks. Here some we are elliptical tubes we are using, and it is separate from the tank walls. And now how to collect the heat from the elliptical tubes which is going to have heated oil. So for that sake, what we are doing is we are going to cool those elliptical tubes carrying hot oil by means of some fans. Some fan we are using externally to cool the what is that, elliptical tubes, and those elliptical tubes they are going to carry the hot oil. Hot oil means the heat which is given by the windings and the core to the transformer oil, and that oil it will be carried by these elliptical tubes, and this will be separated from the tank wall. And now these elliptical tubes will be further cooled by some fans. In this and all these methods they will be coming under oil natural and air forced. Oil natural means oil will be naturally injected, but some compressed air will be blasted to carry the heat from the oil. Then this method we call it as ONAF, oil natural air forced. Then let us see oil natural water forced. Oil natural water forced means here instead of air we are going to force some water. Once again, here you will be having some oil. You will be given, let us see what is this. In this method, the copper cooling coils or pipes are fitted above the core but below the oil surface. So here we are using some copper cooling coils. Coils they are made up of copper or pipes fitted above the core. So some pipes will be there, and those pipes which are made up of copper they will be fitted above the core, because core if it is getting heated means that heat of the core it has to be carried by the copper coil. And then these copper coils they will carry the water, and that water it will be, let us see what will happen. The cool water is forced through these coils. So whatever cold water will be there, that will be forced through the pipes made up of the copper, and these pipes they will be placed above the core which is heated now, or pipes which provides additional cooling where natural water head is available. This method is very cheap because water is cheaply available. For that sake, this method is very feasible. The pipes are provided with fans to increase conduction of heat from the oil. So further, if I increase the more effective cooling, then what we can do, we can fit some external fans to carry the heat. The major disadvantage of this method is in case of leakage of water, the water can contaminate the oil, reducing the dielectric strength of the oil. Suppose if there is any leakage in the copper pipe, then that water may leak into the oil. Because of that, dielectric strength or insulating property of the oil gets damaged. Okay, so this is all about oil natural water force. So here oil will be present which will be carrying the heat, and to cool that oil we are going to force the water, and that water will be forced via some copper pipes or the water tubes which will be placed above the core part, and this method we call it as ONWF, oil natural water forced. Then let us see oil forced methods with heat exchangers. Now here we are going, in both the cases we have seen oil is natural and whereas water or air is forced, but now here we are going to force the oil, we are going to force the oil by some electric motors, pumps and all, and heat, how it will be exchanged. For that sake we are using some heat exchangers. In this method, forced oil, that is OF, is the main feature. The motor driven pump is used to force the oil from top of transformer to the external heat exchanger. So here by the till now oil was natural, directly we are putting the oil, but now here some compressed oil, we are going to use it. So to compress or to increase the pressure of the oil, we are using with the compressed oil with the help of some motor driven pump, from where, from the top of the transformer the oil will be compressed and injected, and then after carrying the heat, then it is sent to the external heat exchanger. Okay, in the heat exchanger oil is cooled with some methods like use of air blast, water blast, etc. The cold oil is circulated back to the transformer. So here what will happen, some compressed air, sorry, some compressed oil, with the help of some electric motor pump, we are going to send it from the top of the transformer. Then that compressed oil, it will carry the heat, then that compressed oil, it will be sent to the external heat exchanger, and in the heat exchanger once again oil will be cooled by some water forced or air forced method, and further oil will be cooled, and the same oil once again it is sent back to the transformer tank. So this oil will be recirculated again and again. So this is all about oil forced methods with heat exchanger. Okay, again in this there are certain methods. Let us see. The oil force methods are classified depending upon how the oil is cooled in the heat exchanger. These methods are, so as I told you, the forced oil will be sent from the top of the transformer to the heat exchanger, but how that oil will be traveling to the heat exchanger and how it will be cooled, based on that there are two methods. First one is oil forced air natural. Oil forced air natural, let us see. The oil is circulated with the help of the pump, and in the heat exchanger it is cooled with the help of natural air. This method is rarely used. So here compressed air will be sent from the top of the transformer, it will carry the heat, then now this heated oil, it will be sent to the heat exchanger, and in the heat exchanger the heated oil will be cooled by natural air method. If this is the case, then this method we call it as OFAN. OFAN means oil forced air natural method, but this method is rarely used. This method is rarely used. Then comes what? Second method, oil forced air forced. Oil forced air forced means, now you only tell me, as the title says, oil forced air forced means here oil will be compressed. It will be compressed with the help of some electric motor pump, and it will be sent from the top of the transformer, and whatever heat will be there, it will be carried by the oil, or whatever heat will be there inside the tank, it will be carried by the oil, and now this heated oil will be sent to the heat exchanger. It will be sent to the heat exchanger, and that heat once again it will be cooled with the help of some compressed air. That will be the help of some fans and all. Let us see that. In the external heat exchanger, the compressed air is blasted. So here you can see that this is my transformer tank, in which we will be having core and the windings, and inside that we are going to have some oil. So you can see here pump will be there. So here oil will be compressed via some pump, and it will be injected inside this transformer tank. Because of this, oil will carry the heat, and now it will be sent to the heat exchanger here. So this hot oil will be sent to the heat exchanger, and in this heat exchanger, how the oil will be cooled. So this oil can be cooled by forced method, air forced method. So here compressed air we are using. So for compressing the air, what method we are using is we are using some fans and all. Because of that, heat can be carried very easily. Okay, the natural air is sufficient. You can see the advantage of this method is at low loads, when losses are less, there is no need to use fans to cool the oil. Suppose if load is less, then heat will be less, then natural air can cool the oil. But if load is more, then some air has to be blasted with the help of some fans. Okay, the natural air is sufficient if load is small, but at higher loads both fans and pumps are switched on by sensing the temperature, which improves the cooling. Suppose if load is more, then I should compress more amount of the air, and I should blast it onto the heat exchanger, where heat exchanger will be carrying hot oil. That hot oil means the temperature of the windings and the core. So here compressed oil, we are going to send it, which will carry the temperature, and it will be sent to the heat exchanger via this wall. Here cooling will take place. If load is small, then natural air can take the temperature from that oil. If load is more, then we should what is that, we should turn on the fans, which will take the heat effectively. So to sense the temperature, whether load is more or more load is less. If load is less means temperature will be less. If load is more means temperature will be more. So to sense the temperature, we are using some sensors there. Okay. At higher loads, both fans and pumps are switched on. So at what time the fans and pumps have to be switched on? So for that sake, some temperature sensors we are going to fit it there. Okay. Hence, sufficient efficiency of this system is higher. The scheme is shown in the figure.4. So this is a circuit diagram for oil forced, air forced cooling method. So here oil forced, air forced means here you can see for large loads this fan will be on, and for small loads natural air can take away the heat. Is it clear? So this is heat exchanger, this is transformer tank, this is the pump to compress the oil, and these are the bushings to carry the extra temperature, and these are the valves to send the oil from transformer tank to the heat exchanger. Is it clear? Yes. Then shall I move to the last cooling method now? So the last type of the cooling method is oil forced, water forced. Can you see this slide, all of you?
Yes, sir.
Okay, so the last type of the cooling method is oil forced, water forced. In the previous case, the cooling method was air. There we are using blasted air, oil forced, air forced. But now here oil is forced with the help of some pump. But here instead of air, we are using the water, forced water. Okay, a jet of forced water we are using to cool the hot oil which is there in the heat exchanger. Okay, everything will be same, only instead of air we are using some water here. Okay, you can see it. In this method, in the heat exchanger, instead of air blast, water blast is used to cool the oil. The pressure oil is kept higher. The pressure oil is kept higher than water. So here, the pressure of the oil will be kept higher than the pressure of the water, just to avoid mixing of the oil with the water. Will be kept higher than water. So oil mixes with water in case of leakage, but water does not mix with the oil. Due to this method, smaller transformer size is sufficient, as it is not necessary to employ water tubes inside the transformer tank. So here we are going to keep the pressure of the oil higher than the pressure of the water, such that in case of any leakage of the water, in case of the leakage of water, it should not mix with the oil. Okay, for that sake, this method is used for small rating transformer. The method is suitable for transformers having ratings more than 30 MVA. So this type of the cooling method, it can be used for the transformers with the ratings more than 30 MVA. This method is used for transformer at hydroelectric stations, as large water supply with appropriate water head is easily available. So here, to exchange the heat, so here this is my transformer for which I am supposed to give the cooling. So here what we are doing, we are going to send the compressed oil, and now after sending the compressed oil, then this oil will be sent to the heat exchanger. So now this heat exchanger, to carry the heat, it will be carrying some water tubes. It will be having some water tubes where the water will be sent here inside, so that whatever oil temperature will be there, that will be easily taken, and it will be carried out by the water. So here water will be cold in state, and by the time it reaches to the bottom, it will be getting as hot water, because it is carrying the temperature of the hot oil. Okay, so this is heat exchanger, that is forced water heat exchanger method. And where we are going to use this kind of the cooling method is in the hydroelectric power plant, like in the case of Almaty power station. If generator is used for producing the power, and if you are using some transformers there for transmitting the power, then those transformers which is having a sufficient amount of water available for the for power generation purpose. So if I want to use the cooling method or cooling for the transformer, then this kind of the method we can use it for hydroelectric stations, as large amount of water supply is appropriate with water head is available. The scheme is as shown in figure.5. So this is the method which we are going to make it use for oil forced, water forced method. Is it clear, all of you? So is it clear? In this method we are using oil, we are using water, but both in the forced state. So this completes your what is that, different types of cooling methods. Now you can see here in the examination they may ask the question like explain cooling methods of transformer. Then what you can do is that first you start to write the answer from this cooling methods of dry type of transformer. First one is air natural, second one is air blast. Then cooling methods of oil movers transformer. Then you explain for oil natural. Then you explain for oil natural air forced, oil natural water forced. Then when it comes to the oil forced methods with heat exchanger, then you explain for OFAN, then you explain for OFAF, then you can explain it for OFWF. So usually it is what I can say 6 to 8 marks question. So you, wherever diagrams are necessary, you draw all those diagrams, you explain for all those diagrams. Okay. So this completes the topic and the concept related to cooling methods of transformer. Do you have any doubts? And I'm going to give the already notes are given for this, just you refer to the notes. It is just theory type of question, what you can expect from the final exam. Is it clear, all of you?
Yes, sir.